First of all, I want to start by acknowledging the team who are behind the scenes as far as this research is concerned. It's a study that I did when I was doing my PhD at Southern Illinois University, Carbondale, which I completed in 2011. And I want to acknowledge, my doctoral dissertation committee at that time. It was headed by Christopher Land. Chris is in here. And I can also see Arjen Hoekstra. He was part of my PhD committee. So as you can see, I was in good hands when I carried out this study. So first of all, what is virtual water and the concept of water footprint? That was originated by Arjen Hoekstra and his team at the Water Footprint Network. The long and short of it, when we talk of water footprint, we are talking about the amount of water that is required to produce a certain commodity. For example, the studies that have been done globally, they show that roughly to produce a kilogram of grain, such as wheat, we would need about 1,000 liters of water to do that, or 1,000 kilograms of water, taking the density of water to be 1. And in contrast, a kilogram of beef would require much more. 15,000 liters of water to produce a kg of beef compared to a kilogram of wheat. And you find that not all places that consume substances actually produce them. People have to trade a lot and import the beef or whatever substance they're using. So when we're importing that bulk commodity, such as grain or its meat from another state where it's produced to a point of consumption, we then talk about virtual water trade. In a way, we are saying some certain amount of water was used to produce the beef, but however, instead of transporting all this bulk commodity, we are transporting the actual substance that is consumed. And we can talk of virtual water trade or transfer to capture the idea that some certain amount of water was used to produce a substance, but now it is being consumed elsewhere. Having made that quick general introduction, I do have some research questions that are guiding my study here. You'll find that by way of background information, the US as a country, it has been identified as the largest virtual water, maybe gross importer as well as exporter. So it's one of the largest net virtual water exporters in the world, the US as a country. But however, when it comes to what is happening locally, among the states, not much has been done to figure out, what's happening in terms of the dynamic situation as far as virtual water imports and exports are concerned. And that brought me to these research questions here to try and tease out what's happening, locally. How much virtual water flows among the 48 contiguous states in the US? And what component of it is blue or green water? These are concepts that have been introduced already. Blue water referring to the water that is withdrawn from surface and groundwater sources, say for irrigation. And green water referring to the water that is actually in the soil root zone that is consumed by plants during evapotranspiration. And I also wanted to know which commodities make up the largest part of the virtual water flows as far as the US internal situation is concerned, and which states are the largest net and gross virtual water importers and exporters. And after answering these questions, what are some of the water management and policy implications of such a study? I'll briefly go through the scope of the study as well as the data that was used. As I have mentioned, the scope was the 48 contiguous US states. And the focus of this study was the agriculture sector, simply because, it is, the main sector as far as water consumption is concerned in the US and maybe a lot of countries in the world. And looking at the agricultural sector, there are a lot of products that you can find in that sector. But the focus of my study was 9 crops and 9 livestock groups that are considered major, at least according to the US Department of Agriculture. There's some categorization that they've done in literature to determine which are the major animal products and which are the major crops that are produced in the US. For example, these 9 crops here that are listed, they account for about 95% of the cultivated area that is harvested. You know, it's one of the ways that these crops are considered major in the US. And for the data, I used data from the year 2008, mainly because, you know, that was the data that was available at that time. And that was more or less complete compared to other years. And also a number of other sources. Let me give a quick overview of the method that I followed. This is a method that was conceptualized by Hoekstra and Chapagain at UCOWR in the work they did at the Water Footprint Network. It was just, you know, a few modifications here and there. But the long and short of it, for the crops, we can start off by looking at the climatic data from climatic databases. And then I used a model called CropWatt, which was developed by the FAO, Food and Agricultural Organization of the United Nations, to model the crop water requirements for each state. So this work I was doing it on a state-by-state basis for the 48 contiguous states in the US. And there's also data pertaining to crop yield. Mainly, a lot of this was from the US Department of Agriculture. And we can actually calculate for each of the crops the volume of evapotranspiration for each primary crop that we used. And for the animals, we can also compute for the 9 major animals that we are talking about, how much feed crop each one is taking, say, on an annual basis. So we also know that, you know, some water is used on raising the animals, maybe for cleaning and doing other purposes, the animal drinking the water. You can actually follow the life cycle of that animal and try to estimate how much each animal is responsible for throughout the year. As a result, we can compute the virtual water content of each live animal in cubic meters per ton. And we can do the same for the crop as well. And after tracking out how much water the animal is drinking, how much food is eating and all that, we can quantify the number of animals that are being traded, you know, between the different states. This was data that was difficult to get, but, you know, at least we did our best, you know, to make estimations. And the same for the crops, the primary crops that we are talking about. And at the end of the day, if we add up the figures for the 9 major crops and the 9 major animals, we come up with a figure for virtual water trade in cubic meters per year for agricultural commodities in each state throughout the US. So this is just a focus on the internal situation between the different states. Let me go and give a quick overview of some of the results that I got from the study. This one here is showing an estimation of evapotranspiration, EVT, of rainfall and irrigation water. If you look carefully, there's a bar that is blue, that represents irrigation water withdrawals, and the green bar represents consumption of rainfall by way of evapotranspiration. And as you can see from this picture, you know, it's a group of states somewhere here in the Midwest where most of the evapotranspiration happens by way of consuming green water. This is mainly, you know, the rainier region of the country. And if we look at the blue bars as well, I think it's clear, you know, the states that are the largest irrigators, you know, in the country. It's evident from this data. And this data is actually broken down according to the primary crops that I was looking at. So if you look at it carefully, cotton, for example, that would highlight, you know, the states, California, you know, Texas, there by way of green water consumption, the states that are responsible for producing these major commodities throughout the country. And if you look at wheat, it's also, you know, evident, the states that are responsible for most of the wheat production in the country and how much they consume when the water is distinguished between blue and green water. These two tables, they're just a summary of states that were selected just to illustrate some of the results that I got from this study. The top one shows virtual water content of the primary crops in cubic meters per ton. And these are the states that are here with a US average of about 538 cubic meters per ton. But as you can see, there are variations between the states, depending on the crops, and also, of course, the conditions that are in the various states. If you're producing maybe corn in Massachusetts, obviously the amount of water that you're going to consume in Massachusetts is different from producing the same amount of corn in California, maybe in Southern California where it is much drier. So it depends on a lot of conditions, the rainfall, the climatic conditions, the soil conditions, and of course, agricultural practices to a certain extent. So this table is giving, that variation between different crops, as well as, between different states that were picked up for the purpose of illustration. And similar results are shown in the table below, but for, this is a comparison actually between the study that I carried out and other global studies that have been done, that also try to estimate the visual water content of crops. As you can see, the results that I have here, they are quite comparable to other global studies where estimates have been made for the US. But in this particular case, my focus was using local data, focusing more on local conditions within the US. And this is the same table, but looking at cubic meters per ton in terms of the animals. As you can see here, when it comes to the production of meat or raising animals, the amount of water that is required, say, to produce a ton for a certain animal is much higher compared to the primary crops. Simply because, also these animals, they also consume some of the food, by way of the crops that we produce initially. And when you look at the crops, when you look at animals rather, you can look at it in terms of cubic meters per ton of an animal by taking, the average weight of that animal. Or you can also make that estimate on a per animal basis. So it's the same table, but this one is showing the results on a per animal basis. As you can see, most of the water that is consumed when it comes to animals, milk cows and beef cattle are responsible for quite a large chunk in terms of the impact or water footprint when it comes to our water resources. These are also averages, from other global studies by Schapagen and Hoekstra 2003, for example, just for comparison purposes. As you can see, there seems to be a good agreement, between the estimates from the different studies that were done. And here is just a snapshot of the water use distributed according to the crops first, and then the animals below. And at the top, you can see that, nearly 332 billion cubic meters of water was used in producing crops in the US. So this is the picture covering all the 48 contiguous states. And the largest culprit in terms of water consumption is corn, followed by soybeans. Whereas, some crops like, say, barley and cotton, they're fairly small, about 2% of this total here. And when it comes to the animals, it's the beef cattle and the milk cows. So as we consume our beef, we need to keep this, in mind by way of the impacts we are having on our water resources, the footprint, as far as our water resources are concerned. And the smallest figure here is, animals such as goats with less than 1%. And here is a combination of all the agricultural commodities. If we look at those 18 major agricultural commodities produced in the US, what is the visual water flow picture? What's the impact on our water resources? When you combine all those, you see some of the largest, users of water still is corn grain, followed by milk cows and grains such as wheat. And this map here, it gives an overview of the net visual water flows within the US. By net here, I mean the gross imports. You appreciate that, each state, much as they produce certain commodities, they are importers as well as importers of certain commodities. So here, I was calculating the net visual water imports and exports. And from this map, we can see that, the top net visual water exporters, they include Nebraska, Illinois, North Dakota, Indiana, mostly states that are within the Midwestern region that is responsible for most of our agricultural production. And the net importers, they include, most of the Atlantic states here, where most of our population is concentrated in. Those tend to be, some of the major fish or water importers. That includes maybe Massachusetts, of course, in the east. But overall, the total annual gross export was about 121 billion cubic meters per year, and total gross import was about 128 for the US contiguous states. And here is the same picture, but looking at the animals. And we see that, a state like Illinois is one of the major fish or water importers. Whereas places like Iowa, California, Wisconsin, there are some of the states that are responsible for feeding the rest of the country as far as animal production is concerned. And this picture here, we have combined all the agricultural commodities, both animals and crops. And the picture, I think, is self-explanatory, more or less. Is this region here that is responsible for feeding the rest of us. So all the red areas, they tend to be the states that are impacting our water resources the most in terms of consumption. They import a lot of agricultural products, agricultural commodities. And the green states are the ones that are exporting to the red areas. And we can look at this analysis on a per capita basis. If we divide by the population for each state, because sometimes if we want to look at the picture, it can be misleading. Idaho or North Dakota can be a net fish or water exporter, but we need to factor into account the population as well to see how the picture comes up. So for this one is the picture for crops and animals, but is normalized by population for each state. And as we can see, the top agricultural per capita net fish or water exports include North Dakota, South Dakota. But it's interesting to note that those particular states, much as they are the top net fish or water exporters, they only account for 0.2 and 0.3% of the national population. So we are impacting the water resources in those states a lot. But at the same time, those states, in other ways, they actually experience a lot of externalities that are associated with producing those particular commodities that are being consumed elsewhere, within the country. And the top agricultural per capita importers include Delaware, Alabama, which have only 0.3 and 1.5% of the national population. So these states, they are huge consumers in terms of the imports that they do as far as agricultural commodities are concerned. But the production is happening elsewhere within the country. So those sort of results, I think, they've got implications in terms of managing scarce water resources in the areas where the production is happening and also the areas where the consumption is happening. There could be a lot of water resources in some of the production areas, but there are also externalities that we should keep in mind that are associated with that agricultural production that is happening elsewhere in terms of the spatial location. And this is a table that is summarizing, the overall picture, when it comes to the results. And from this calculation, I made a calculation of what I called the agricultural water footprint of US states. And there I was taking, following some of the earlier work by Arjen Hoekstra and the network, water footprint network, I took direct water consumption. Say if you're producing corn, there's a certain amount of water that we're withdrawing, say, to irrigate the corn. And then there's also some water that is consumed in an indirect way, say to produce other commodities that are then used to produce that same amount of corn. So if we add the direct consumption plus the indirect, then we come up with a figure that we can call, the water footprint of each state. And from this result, the US agricultural water footprint, I found a figure of about 500 billion cubic meters per year, or on a per capita basis, when we normalize by the US population, about 300 million or so, we come with 1688 cubic meters per year per capita by way of deriving an indicator of some of the impacts of consumption on our water resources. And if we look at individual states, there's water footprint on an absolute basis. One of the largest states in terms of impacting our water resources in absolute volumes is California. It actually ranks one with more than 60,000 million cubic meters per year. But if we factor in the population on a per capita basis, then the largest water footprint is found in Nebraska. So it's a huge agricultural state, but at the same time, once we factor in population, most of the impacts that are felt in Nebraska is other states or other parts of the country that are responsible for that. And so goes the ranking for all the states. And you'll find interesting cases here. Rhode Island here is one of the lowest in terms of the absolute figures. New York, on a per capita basis, is actually the last on the list of states that I considered. And this is just a mapping of the same results. In this case, I'm looking at the water footprint of US states in million cubic meters per year. That is in absolute terms. And as I've said, one of the largest states that are impacting our water resources, that's California, Texas, maybe a lot of beef production in Texas, Florida, Illinois, most of the states I would say that are along, the Atlantic coast. And the list includes states like Maine, New Hampshire, North Dakota, Rhode Island. And these are the same results that have been normalized by population. Water footprint per year, per capita. And as I said, the largest, Nebraska, followed by Iowa, South Dakota. That is the ranking that I showed earlier on in the table. Some of the smallest ones include, states like Connecticut, Rhode Island, and New York. And as I showed earlier on, one of the research questions, we are saying we are not very sure what the facial water state picture is within the US. So one of the interesting things to do in deriving such indicators is to try and compare how significant are those facial water transfers that are happening within the country. So to get a quick picture of it, we can make a comparison between facial water transfer, the net imports or exports. If the bar is above, say a state such as Alabama, then it means it's a net facial water importer. If the bar is below a state such as Nebraska, it means it's a net facial water exporter. So you can actually make a comparison of that red bar with the gross facial water import, the blue water withdrawals, and also evapotranspiration from rainfall to see how significant those volumes are and whether they've got any implications in our management of water resources. So we found that, the US net facial water exports, they're actually less than 1% of the withdrawals, less than 2% of green water use, and also 1% total water footprint, which means, in other words, the national totals are actually dwarfed by the illustrated interstate facial water flows. And before I conclude, just a rundown of the research questions again. How much facial water flows among the 48 contiguous states? What component of this is blue and green water that has been illustrated from this study? Which commodities make up the largest part of facial water flows? This has also been illustrated in this study. Which states are the large net and gross facial water importers and exporters? This has also been answered, through this study that I carried out. So at the end of the day, what are the implications in terms of, policy and managing our water resources? So despite the large water footprint per capita, the US is the leading net facial water exporting country, with about 5 billion cubic meters. But, this global figure that has been found in other studies, it actually masks the important facial water flows that are happening at local level, that is among the states. And of course, in terms of the pattern, this study has shown that facial water flows primarily from the rural and agricultural north central region to the populous, urban and Atlantic coast states. And you'll find that this mirrors international trends that can be explained partially. You can explain it in terms of comparative advantage, where soils are also a complement to the availability of water, states such as North Dakota, etc. And the Southwest region, the dry region, California, New Mexico, going west, is nearly vegetable water neutral, but could become a net vegetable water importer like the East. You know, that way they can reallocate their scarce water resources to other sectors, maybe where they have high value uses, such as, you know, industry, etc. So it's channeling most of our water in the water scarce states to irrigation, the most efficient way of using our scarce water resources. These are issues, you know, that we can always talk about as policymakers and as decision makers. Thank you very much for your time. This is just a selection of some of the references that I used for the study.